In this lesson, we're going to be solving polynomial equations by factoring and using square roots. So it depends on the situation of which of these we're going to end up using. So the first one is 9y squared minus 36 equals 0. Now we could use factoring, but we can also use square roots. The idea of a square root is a lot of times these are going to be trinomials where you have three terms. This one's missing the middle term. Anytime that happens, you can use square roots to solve it. So to do that, we're going to isolate the y squared so we can square root both sides. So we're going to add 36 to the other side. So that's going to give us a 9y squared equals 36. We'll continue to try to isolate the y squared. Divide both sides by 9. That'll get us a y squared equals y squared equals 4. And then to get rid of the square, we're going to square root both sides. So y is going to equal plus or minus 2. So don't forget that if you bring in the square root to solve, you're always going to get a positive and a negative of that square root. So if you plug 2 back in or you plug negative 2 back in, either one is going to square, and so that negative and the positive would both become positive or stay positive. So those are your two answers. So we can just square root if we're missing a middle term. Now that's not always going to be the case. So here's another look. Z squared plus 64 equals 16z. So this one is missing a middle term, but it's actually over here. So in order to do this, if we're going to be looking to factor, we're going to want to get everything over to one side and eventually use the zero product property. So we're going to move the 16z over, and that's going to get us a z squared minus 16z plus 64 equals 0. So we're going to try and factor, and we're looking for a z times a z. Two numbers that multiply to 64 that are going to add up to negative 16. Signs are going to be negatives because this tells us signs are the same, both negative. 1 multiplies to 64, that adds up to 16, 8, and 8. So now we'll set each factor equal to 0 and solve. So we'll add 8. We'll add 8 on this one as well. And that'll get us z equals 8. And z equals 8. So we get the exact same answer. All right, let's try another. So if we have 11x equals negative 12x squared minus 2. So not quite the same look as number 1 because that middle term again is right here. So we know we're going to have to factor this. We want to get everything over to one side, make it equal to 0, so we can factor, use the zero product property. But I don't want this to be a negative if we're going to factor. This is going to be our leading coefficient. So we're actually going to bring these two pieces over to the other side. So we're going to add 12x squared, and we'll add the 2 over. So if we do that, we'll have a positive 12x squared plus 11x plus 2 equals 0. All right, so to solve this, we could either try and factor it right away, or we can use the AC method. Maybe we'll try the AC method because there's a couple factors of 12x to make it a little bit more complicated if we're just going to try and factor it. So AC method is we're looking for, this is our A, this is our C. So we're looking for two numbers that multiply 12 times 2 to 24. So we need numbers that multiply to 24 that are actually going to add up to 11. All the signs are positive, so they need to add up to 11. So 3 and 8 are going to be our numbers. So that is exactly how we break this apart. So if we have a 12x squared, it'll be a plus 3x plus 8x plus 2 equals 0. So AC method, basically all that is that it's going to tell us how we break apart our middle term, and then this turns into a factor by grouping problem. So what can we factor out of these two? We can factor a 3x out, which would leave us with a 4x plus 1. And in order for this to work, we need another 4x plus 1 equal to 0. What can you factor out of those two to make a 4x plus 1? We could factor a 2 out of it. So what do they have in common? 4x plus 1. And we could factor 4x plus 1 out. That would leave us with a 3x plus 2 equals 0. Okay, now once we have our factors, just like number 2, we're going to set our factors equal to 0. So 4x plus 1 equals 0, 3x plus 2 equals 0, and we'll solve each one. So we'll subtract 1. That'll get us a 4x equals negative 1. And then we'll divide both sides by 4. So x is going to equal negative 1/4. So there's one answer. And we'll go back to do the other one. Subtract 2 to both sides. That'll get us a 3x equals negative 2. Divide by 3. X is going to equal negative 2/3. And those are our two solutions. All right, so we'll do a couple more. So number 4, we'll take a 3x squared equals 21x minus 30. So we want to rearrange everything, keeping the x squared positive if we can, which is great, which means those two terms are going to come over. So if those two terms come over, they're going to subtract. We'd subtract the 21x and we'd add the 30 to bring it over. And you'd have nothing left on the right side. So before we try to solve, let's try and factor anything that we can. They all are divisible by 3, so we can factor out a 3 out of every piece. So we'll divide everything by 3, divide everything by 3, and we get x squared minus 7x plus 10 equals 0. Now we'll look to factor. Don't lose your 3. So this tells us the signs are the same. This tells us they're both negatives. And we need numbers that multiply to 10 that add to negative 7. It's going to be a 5 and a 2. So we set each factor equal to 0. X minus 5 equals 0. X minus 2 equals 0. And even the 3 equals 0, even that factor. Now this one doesn't make any sense, but sometimes there's a variable attached to this, which is going to get you another solution. This is not one of those cases. So we just have two answers. We'll add 5, add 2, and that's going to get us our solutions. So x equals 5, and x equals 2. All right, plug them back in, make sure that they work. Plug the 5 in here, plug the 5 in there, see if they add up to the same thing. Do the same thing for 2. All right, last one. 2x squared plus 3 equals 0. So this is very similar to the first problem. We're missing the middle term, so we could just try and isolate the x squared and square root both sides. So we'll subtract 3. So that would get us a 2x squared equals negative 3. Divide by 2. So that's going to be x squared is going to equal a negative 3 halves. We're going to bring in the square root to solve. And we got a little bit of work to do. So we're going to break this up into a negative root 3 and the 2. We'll just apply the negative at the top. Now we need to rationalize the denominator. So, and we're going to have square root of a negative. So we have two things that we're going to have to deal with here. But to rationalize the denominator, we're going to multiply top and bottom by a square root of 2, making the denominator a perfect square. And multiplying the top together, that's going to get us a negative 6. So we can't square root a negative 6. The best that we can do is take the negative out, which turns into an I. So that represents the square root of a negative. And then on the bottom, we have 2. So our answer is we brought in the square root to solve, so it's a plus or minus I square root 6 divided by 2. And we have 2 answers. All right, and that's solving polynomial equations by factoring and square roots.